Hello and welcome to another installment of the Algebra 1 video series. This is Unit 2, Section 2, Slope of a Line. And our objectives today, we want to identify the slope of a linear relationship as 0, positive, negative, or undefined. Determine the slope of a line from a graph, a table of values, or ordered pairs. And interpret the slope in context of a real-world scenario. So, I didn't realize this, but I guess that I had really talked about a lot of this in the previous video. So we're just kind of reiterate that and review that. But, the first thing, I want to talk about is, when we talked about the rate of change in the last video, we also called that the slope of the line. Okay, and remember, slope is a measure of steepness. So the measure of steepness. A measure of steepness. Okay, so, it's the ratio of the change in the dependent variable, the y values, with respect to the corresponding change in the independent variables, the x values. So, usually when you think of slope, I'll use the variable m. You think of the rise over the run, okay, which is also the change in the y values divided by the change in the x values, which is also given to us as y sub 2 minus y sub 1 over x sub 2 minus x sub 1, all right? And so, in this, it shows you, this rise over the run, the rise, that's the same thing as the change in y. Okay, and it's really just the distance of this triangle, okay? And then the run is the change in x, okay? So that's what we've got, all right? So we've talked about this before. Okay, the graph below here shows the cost C of L pounds of lemons, okay? And what we do is we can actually figure out the if we take the slope of this line, if we do the rise over the run, and basically what you do is you go from point to point, you make a right triangle, like a stair-stepping triangle, and as long as you get the same triangle between each point, that you have a constant slope. Okay, so if I take if I were to find the slope of this line, m is equal to a rise of 1 over weight, which is which is 2 pounds. So $1 per every 2 pounds, which is the cost of the lemons. Okay, so and what they do, you see this kind of thing all the time. What this gives us, if we were actually to divide these numbers, okay, if you take $1 and you divide it by 2, that means that you are paying 50 cents, so 0.50 cents per pound of lemons. And you see this all the time at the grocery store. And this is a rate of change, okay? Depending on how many pounds you buy, that affects your cost, okay? And it's a linear relationship, okay? All right, so the next thing I want to talk about here is that lines can have a positive slope, where they go in this direction, a negative slope, 0 slope, or it's undefined, okay? And so, the way I do it, I make a picture, okay? So when I'm trying to figure out the sign / types of slope, all right, you've got 4 options, okay? And you've either got a positive slope, you've got a negative slope, you have a 0 slope, or it's undefined. So if your line looks like any of these, then you can tell which one it is, all right? Okay, for this next page, let's go ahead and take a look at this graph. And it says that the graph below represents one side of the roof of the building. So this is the vertical distance. And the other is going to be the horizontal distance. And it says the slope of the line is what? So let's go ahead here and let's go from one point to the next. And this looks like a change of 7 over a change of 2. So our slope, m, is equal to positive 7/2. Okay, since it's going in this direction, I know it has a positive slope of 7/2. Okay. And the next question, it says, we're given a table of values. And it says that Jonas loaned his sister $67.50. She pays him back with her allowance each week. The table below shows how much money is still left on the loan after the first 4 weeks of the repayment. So what we want to do is we want to find the slope of the line that runs through the points in that given table. And we want to kind of figure this out. So what I would do is we want to just figure out how do these numbers change. And we did this in the last unit, but I'm going to go, okay, every one of these x values changes by 1, okay? And we're going to call this part the y value, and we got to figure out how these change. And so these numbers are kind of hard. So in order for me to figure out how to go from 67.5 to 51.75, for me to do that math in my head is a little tricky. So in order to figure out the difference between the two, I subtract this number from this number, okay? Or actually, I subtract 51.75 to 67.5. So let me do that real quick. And that's going to give us, okay, 51.75. Let me write this down. So 51.75 minus 67.50. 67.5. And that's going to give me 1575. Okay? And so that's one of them. All right? So I know that this difference is 15, and it's negative 1575. Okay? And that's minus money. Okay, let's see if we get the same thing from these two values. Let's do 36. So 36 minus 5175. So 36 minus 51.75. And that gives us the same thing. So we're going to get the same thing. We get negative 15.75. And even here, from 20.25 to 36, so 20.25 minus 36 is going to give me the same thing. Going to give me negative 15.75. So what I do is I just take these numbers here, the 1 and the negative 15.75, and that helps me calculate my slope. And so my slope, m, is just going to be negative 15.75 divided by 1. Now, let's actually take, this into consideration. Okay, this is dollars per week. And so it kind of, it tells us how much, gives us some information, gives us the rate of change. We know that Jonas's sister is paying this off at a rate of negative $15.75 per week. Okay, that's what we're looking at. All right, take a look at the next one. And so the table below shows the gallons of fuel remaining after a car travels at a certain distance in miles. So what happens is that you start with a certain amount of fuel, and then as you drive, that amount of fuel goes down. So what we can tell here is that the distance increases by 1 mile for each of these values, okay? And this is an x value. And then the fuel remaining in gallons is a y value. And this decreases by a value of 4.04 minus negative 0.04 gallons, okay? So negative 0.04, and this is constant, negative 0.04, negative... Oh, dear. 0.04. Yeah, you get the idea. All right. So they all change like that. And it says the change in fuel remaining from one row to the next in the table is negative 0.04. It's decreasing. Okay? And then it says the change in distance from one row to the next in the table is 1 mile. Okay? So the slope of the line that runs through the points in the given table is negative 0.04 over 1, okay, and the slope indicates that the car uses uses 0.04 gallons for every mile, okay, or you could say the amount of fuel is decreasing. Yeah, you should say that. The car uses 0.04 gallons for every mile, but you should say that the amount of fuel decreases by 0.04 gallons for every mile. Okay, so you should say that it goes down and give it a value. All right, so they finally they give us the slope formula, okay? And, you know, what we have is the slope formula can be calculated by using the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I've already written this down a number of times. But the difference is that you have these points, okay, where you have x sub 1 and y sub 1 and x sub 2, y sub 2. Now this, okay, is the first point, okay, and that's indicated by the little ones that are below the x and the y, okay, and this value over here, I'm going to make this a different color, is the second point, okay, and so, you know, we use this formula because, you know, what we want to do is we want to calculate the distance here, the rise, okay. This is the same thing because here's the value y sub 2 and here's the value y sub 1, okay? And then here's the value, say, x sub 1, and here's the value x sub 2, okay? So the question is how do you come up with these vertical and horizontal distances, okay? How do you come up with the distance between this point and this point? So what is this? 1, 2, 3, 4, 5. Okay. So we know, let's just look at this. This is a value of 6. Okay, y sub 2 is at 6. Y sub 1 is at 2. All right. And so the question is like, okay, I know that the distance between these 2 points, if you count it, goes up 1, 2, 3, 4. We have a distance of 4. But how do I use these numbers, 6 and 2, to get a value of 4 as my rise, okay? And so what you would do, all right, to get 4, that's equal to 6 minus 2, okay? And it's the same thing over here, okay? This is a value of, say, 3, all right? And this is a value of 7, okay? And we know that the run is a value of 4 as well. So how do you get 4 from using the numbers 7 and 3? Well, and you just do 7 minus 3, okay? So you do top minus bottom, right minus left, and that gives you the values, okay? So I don't know necessarily why that's there, but let's just take a look at this over here. And it says find the slope of the line that passes through the points 2, negative 5, which is right here, and then 7, 1. Okay, so let's just go ahead and, you know, let's choose which one we want to do first. Typically, and it doesn't matter which one you do first, the math will always work out the same, but let's just kind of make it look like the picture above. So I'll choose this one to be x sub 1, y sub 1. So I'll have that be the point 2, negative 5. Okay, so that means that x sub 1 is equal to 2, and that y sub 1 is equal to negative 5. All right, now let's go ahead and identify x sub 2, y sub 2. And so I'll have that just be the point 7, 1. And so I know that x sub 2 is equal to 7, and that y sub 2 is equal to 1. All right, now before I do anything, I'm going to go ahead and draw the my triangle here. All right, we'll do it the old-fashioned way. And we'll go, okay, this is a length of, okay, go up 1, 2, 3, 4, 5, 6. So the rise is 6. And then my run is 1, 2, 3, 4, 5. Okay? So I know that my slope is my rise over run, which is 6/5. Okay, we're going in this direction, so it's positive, so we're good. But let's go ahead and use these numbers. Okay? Now, I knew that my rise was 5. Now I'm going to write out my slope formula here. I'm going to say that m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, and so I'm just going to go ahead and substitute my numbers in. And so I get a y sub 2 value of 1. So I'm going to do 1 and then minus, and then my y sub 1 value. Okay, plug that in, negative 5 into that. And that's going to give me negative 5, okay, and then divided by x sub 2, which is 7, all right, so I'm going to do 7 minus my x sub 1 value, which is 2, Okay, so if I go ahead and do this math, it's going to give me 1 plus 5, which is 6, and then 7 minus 2, which is 5. Okay, and that's it. And, you know, you just have to think about, okay, how do I get the distance between 1 and negative 5? What's that distance? Well, that's a distance of 6. Well, how do I come up with that distance of 6? Well, you take the top y value and you subtract the bottom y value. All right, same thing over here. Okay, this is a value of 2, and this is a value of 7. Okay, these x values here and here. How do I get a distance of 5 between those? And you subtract them, right minus left. So top minus bottom, right minus left. And that's it. Okay, the last one says just find the slope of the line that passes through the points. And so you can take any two of these points, and again, I'm just going to go, okay, these values, okay, from negative 14 to positive 7, what do I do? Okay, what am I doing? And then maybe from negative 7 to 0, what am I doing? And then what are the, so basically these numbers are increasing. By how much? Okay, so we add 7 to get from one to the next. We keep adding 7, okay? And then what about for the y values? These numbers are getting smaller, okay? So go from 8 to 6, well, you're just subtracting 2, okay? From 6 to 4, you're subtracting 2. Subtracting 2, subtracting 2. Okay, so then our slope, okay, the change in y, these are the change, okay? So my slope m is equal to negative 2 divided by positive 7. And that's it, folks. Slope is really fun. I hope you enjoy it. We're having a good time. We're always having fun. See you in a bit.